and above the 3D depth camera, we have the SDK. And the SDK provides a bunch of capabilities. I'm going to go through some of them in a moment. And we use all these capabilities to provide a more intuitive and natural interactions. So first, I want to talk to you a little bit about the 3D depth camera. So in 2013, we released the peripheral creative camera. It's the one you see on the top. And this camera, like I said, was a peripheral camera. It was released along with the RealSense 2013 SDK for early developers, just to get a concept of what's the 3D depth camera is. Just recently, we released the 2014 RealSense camera, the one you're supposed to receive or already received. This camera is very thin. It's going to be embedded inside all-in-ones, two-in-ones, and eventually laptops, tablets as well. It's very power efficient, and the goal of this camera is actually, like I said, produce 3D depth data. Now, I'm not going to go very technical with you, but just to give a short concept of the depth data, there are several ways to get a 3D depth data, and this camera is basically based on time-of-flight technology, which means that it emits a certain signal, and it measures how much time the signal takes to hit an object and comes back to the camera. And then it can actually understand how far is the object according to how much time it took it to hit the object and come back to and go back to the camera. So when I tell people about this camera for the first time, usually the first thing I'm being asked is, so what's the difference between this camera to Kinect? Well, like I said in the beginning, there's a major difference between these two cameras. The first one is that this camera is designed for close range interactions. When you look at Kinect, for example, it is aimed for a full body for a farther range. But this camera is aimed to be interacted with integrated inside tablets, and like I said, all-in-ones, two-in-ones, which means we want the interaction of the user to be close to the computer, close to the compute device, and being able to interact with it with his hand, very near to the compute device. So we're talking about 20 to 120 centimeters. And the second thing is that this camera has to be very thin, like I said, very power efficient as well, because we're talking about mobile devices, and we want this camera to go along with them. And this actually creates a major difference between these cameras. So before I'm going to actually show you what a 3D depth data is. But just before we go into that, I'm going to show you, talk a little bit about the SDK itself. So the Intel RealSense SDK actually understands 4 basic type of inputs. The first one is the hands. We're talking about 22 points on the hand, including joints. We're talking about gestures, whether it's static gestures or dynamic gestures. 2 hands and more than that, multiple hands. It can understand whether it's your right and left hand, and so forth. The second one is the speech. We're talking about voice recognition and text-to-speech capabilities, command and control mode or dictation mode. The third one is face. We're talking about face recognition and face detection, multiple face detection actually. We're talking about 78 points of landmarks on the face. That's 78 points like the tip of the eye or the nose and so forth. And about, of course, we're aiming forward towards other capabilities like pulse estimation and so forth. And the last one is the environment. And the environment is very important because, like I said, all the three types of inputs that I've talked to you about right now were related to understanding the user. But in order to understand the user completely, you actually have to understand him in the right context, in the right environment that surrounds him. Meaning, who is he with? What surrounds him? So, just to give you a quick list of the SDK, like it's not a complete list, but it's definitely provides you the main areas. So when we talk about environment, we talk about background segmentation, about 3D and 2D object recognitions, understanding what objects are around the user. Scene perception is something that we are looking forward to bring in the future, and augmented reality capabilities. I'm going to give you later on a short concept of what does it all mean. So maybe we should just have now a quick look about the SDK itself. I don't know how many of you guys got the camera already. So I'm gonna, let's see, first of all I can see, Pierre, I can see I don't have the questions tab, so that means either there are no questions or I can't really see anyone's questions if there are any. So
okay.
I want to give you, like I said, a quick look about the SDK itself. Let's have a look here. All right. There we go. I'm going to start with the depth data. Now you can basically see me, and you can see the distance of me from the camera. I'm going to take down my jacket because it's a black jacket, and black objects observe all the signal that the camera emits. So now you can see basically me. You can see how far I am from the camera. If I go back, you can see the difference. If I go nearer, and this is the raw depth data. Well, actually, it's a bit smooth, but let's not get into it right now. And if I show my hands, you can see how the SDK understands my hands. We can actually have all the points on the landmarks. I can play with my hands. I also wrote to him to check for a fist gestures. You can see when I close my hand, there's a fist gesture being emitted. And I can actually play with my hands. You can see it's very flexible, very accurate. And of course, if it understands which hand is my right hand, my left hand. So this is just a quick concept. One second. I see now we have some questions. All right. So, okay, let's continue. The next thing I want to show you is basically the face tracking. So the face tracking, if I open it right now, if you can see now, let me know when you can see me. There we go. So you can see the 78-point landmarks on my face. You can see how when I move, the points move with me. You can see that on the right side, or whether it's on your left side, the expressions. You can see when I'm smiling, the smile changes when I'm surprised. Basically, this understands, gives an amount, a certain number of that indicates the expression that I'm currently posing, and also provides the pose detection, whether I'm leaning forward, whether I'm leaning backwards, and so forth. It has the Face ID, which means who am I? If I press the register here, it will recognize me. When I leave the screen and go back into the screen, it will understand I'm the same user. So this is the face detection. And the last thing I want to show you is actually the 3D segmentation. It gives a really good concept of what a 3D depth camera is. So now you can see how it segments me. It understands that I'm the object that's near the camera, and it actually hides the entire world behind me. If I put my hands here, it will show only me and my hands. Now if I go backwards to a certain point, it will actually hide me and put me as part of the background. But if I get closer, it will show only me, and it segments me out from the external, from the rest of the world. So all right, let's continue now. I want to talk to you, the next thing I actually want to talk to you is about how we use all these capabilities to create augmented experiences. And the first experience I want to talk to you about is the digital storytelling. In order to, so far I've been talking a lot about how we want to create an immersive experiences in more natural and intuitive experiences. And the first thing we actually decided we want to take it towards was the digital storytelling. So far, the books and the storytelling has been, well, you're taking a book and you're having a look at it, and then you're starting to read it, and you decide whether you like it or not. Then this means whether you get immersed in it or not. But we thought, well, why don't we take it to the next level? Why don't we have a look if we can actually change the context of the book, and in order to better engage the audience? Why can't we engage the person, have the person more engaged inside the book? So in order to do that, we actually created something we called an immersive digital storytelling. which is actually taking a certain book we created called Uncle Jeff's Funky Farm. And you can see the book here. I'm going to show you a small demo in a second. And the concept here, like I said, was having the user more immersed inside the book. So let's have a quick look. All right. So here you can see Uncle Jeff's Funky Farm. All right. On the left side, you can actually see the user holding the book. And once we show the book, you can see the farm. Let's say this is a butterfly. This is the butterfly scene. So once the user shows the book, a virtual butterfly appears in front of the book. Let's maybe make it a bit lower because the music doesn't really contribute. And now once the butterfly appears, the user can actually play with it and move it, push it forward, take it backwards. And then afterwards, of course, show the book and have the butterfly go back into the book. Let's have a look about several other scenes. I'm going to show you just the more interesting ones to save our time. So here in the next scene, not in this one, just about to start, there we go. You can see how the user can actually see himself inside the book. You can see himself coming out of the computer screen. And this uses actually the 3D depth segmentation in order to segment the user and put him inside. And there in this scene, we can see the face detection, the tracking. You can see how the user appears inside the billboard. And basically, if there were several users behind them, we could see how we can switch between one user to another. Maybe the last nice thing to show here would be the portal to the portal to the world. So you can see how the user uses the book now as a portal to the virtual world. He can actually move the book around, have a look at the virtual world from different angles. And this actually depends as well on the camera's point of view and angle. So let's have a look. Now I see we have a bunch of questions. So I'm going to read the questions because I don't know how many of you can actually see them. So the first question is by Ayman asking, is there a link describing the hand information received from the SDK? So first of all, this is actually a good question. So all the information that's being received from the SDK is being described very thoroughly inside the documentation. Once you install the SDK itself, you can see the documentation folder inside the SDK path. So once you go there, you can actually have all the information you need, exactly what's the raw depth data that's being provided, how you get the hands data, and how you can use each one. The next question is there a way to reduce the frame rate for less than 30 frames per second? I'm not really familiar with it. Not really sure about it, actually. I'm not really sure. So we have another question about scene detection. I haven't configured my cam yet, but can you just point out the cam towards some object on the table? Well, yes, and I'm going to show that in a moment. Steve is saying about segmentation. Segmentation works very unreliably on my system, only about 25% of the time. Usually I just see the faded background. Is there a known problem with 3D seg sample code? Well, first of all, no, there isn't any known problem that I know of. It's important to say, though, that the segmentation data, and in general, the camera's data depends a lot about the environment you're in. So if you have, for example, a reflective material behind you, like a glass or a mirror, that basically can cause noise and interferences. Or, of course, if you're wearing black, so like I said, black actually absorbs all the signal and doesn't allow it to go back to the camera, so you don't really have the camera doesn't really receive any depth data. In any other case, you should basically get a really you should get good data, decent data like the one I've showed right now. There shouldn't be any real issue with it. Let's continue then. So the things you've just seen right now, like I said, is how we take the virtual world and bring that into how we take the user and bring him inside into the virtual world. But the concept of the camera is actually having the users integrate inside their environment in the 3D world. I'm sure you're all aware of this situation where people are sitting inside a restaurant and a couple of people sitting, and each one is actually engaged with his own phone, device, tablet, whatever, and instead of interacting with each other. And this is people who are talking about being engaged in a 2D screen. But when we look at it, we actually already know that the world around us is a 3D world. And it's much more appealing to our senses. And we're asking, why can't we bring people, having them interact with each other, having collaborative interaction, and with their devices in a 3D environment, in a 3D world? So I want to show you several examples right now. And the first one is what we call another demo with our famous Uncle Jeff. It's actually, it's made out of 2 videos. I'm going to break one in the middle and show you the second one. But it's called a farm on the table. And in this demonstration, we show how we take, instead of taking the user and bringing him into the virtual world, we're going to take the virtual world and take him out into the real world. So in order to do that, we use augmented reality. We take a marker, and now once we start the demo here, you can see the farm coming out on the marker, on the real world, on our tablet. And we use the 3D depth camera. We aim it towards the table, and we use it in order to understand the surface around it. We understand that there is a table, and later on you will see how we put some other objects, and we understand that these objects are actually there. So I'm going to give it a few seconds. So once we have our Uncle Jeff coming out of the screen, we can actually, what's going on here? Oh, there we go. We can actually see him coming out from the farm into our table, walking on our real table. So we're talking about a virtual object interacting now with our real world, walking on a table around us. I'm going to stop here and show you another photograph of this demo because I think it will be better explanatory. There we go. So the next thing I want to show you is how we add some more objects into, let's make it a bit quieter, into the environment. The first thing is actually we plant grass on the table. So you can see how the grass stops on the edges of the table and it doesn't continue outside. And in order to do that, we use actually the 3D depth data. We use the camera, and we understand that there's a table here, and behind it there is a different environment. At the next part, we have this island right here. We want to have Uncle Jeff going up on it and rescuing the sheep that is being stuck on it. So in order to do that, we use a physical, actual, real ramp. And then because we have the 3D depth camera, we can understand that we have a 3D ramp here, and we can segment the data. We can understand that there is a different size. And here now you can see Uncle Jeff climbing on it. So you can also see, for example, this the snow piling over the ramp. So this is another nice example. And here you can see, like I said, virtual elements, augmented reality, and virtual objects appearing on the real world. And another nice example of it is the one you're just about to see right now. We call it the tractor example. We have a ramp here, the same ramp, and this time we have a small tractor that's going to try and climb over this ramp. And because we have a 3D depth understanding, we know that there's a climb around it, and we know that behind it there's a descent. So the tractor, as you can see, we use a physical engine in order to simulate. And then you can see how the tractor is having a hard time climbing up, and the moment he climbs up, he's going to have a really easy way going down, or almost easy way going down. Oh, there we go. So this is one example of how we use the environment how we have environment understanding. I think there's also a small session here. All right, that's about it for now. So this is one, like I said, this is one example for environment understanding and how a person can interact with the environment around him. Another nice example would be some small demo we called AR Pet. So in this demo, you're gonna see how well the demo. The name itself is self-explanatory, but the point is actually showing you how we use augmented reality and how we added to the augmented reality experience the occlusion. In order to do that, we use the 3D depth data in order to understand where the hand is located in the real world, and then decide whether we hide a certain object or not according to its location. So you can see first of all a sample of how we understand the hand's location in the depth in the 3D world, and how we basically take it into the virtual world. And you can see how the hand can push the ball or play with the buttons, or definitely it can also hide the ball behind it. The next thing is actually, like I said, the AR pet. So we're going to move to the next scene. Sorry. So here you can see how we have an entire environment, and the user can actually interact with it with his hands. He can play with the leaves, push the buttons, push the rocks, and once he breaks the egg, there's his virtual pet, the dragon, coming out. He can play with the dragon. He can hold him and push him around. He can make him burn the trees, hide him with his hand. So you can see how he can play with him. He can push him, and then the dragon starts firing, throwing fire, and there we go. And then he can actually hold him with his 2 hands and blow it apart. All right. So I can see we have now here a pile of questions. Let's see. Let's go over it a little bit before we continue with the demos. So we have here, hi, I just wanted to know if a Unity free integration is planned. If yes, when it will be available. So definitely a general question. I will try to leave it towards the end when I get to the Unity part. But in general, well, let's leave it for later. All right. RSSDK Java library. Again, general questions about the SDK. If they're not related to the demos, I try to treat them in the end. Another question we have here is about 3D segmentation problem that we've already talked about. So again, let's try and leave it towards the end. All the general SDK issues, if they're not related to the demo, I will leave 15 minutes at the end, and then we'll try to talk a bit about technical issues. All right. So you've seen so far how we take the virtual elements and how we take the user and put him in, have him interact with the virtual world, or how we take the virtual world and have him and bring the virtual world back here to our reality. The next thing actually I want to show you is how we take real elements, real objects, and use augmented reality in order to have a better interaction with them. So in this case, we have what we call an AR kit. We have a real dragon, and we use augmented reality in order to show how he's throwing fire. And if we had a Lego tree, for example, and we throw the fire in it, you can see the tree burning. Now we can actually bring our fire truck, and there we go. And you can see how we augment the smoke over the fire truck, and we use the water to turn turn off the fire. This is a very nice sample of how we can have kids actually playing with their actual toys and still having a better interaction with it. Another small sample of concept is how we use diminished reality. We basically burn the tree, but now the tree is actually disappearing. You can see how the tree is actually disappeared after we burned it. So, all right, let's continue. So, all right, so far what you actually seen is how we have different types of interactions of the user, whether it's the user having the virtual world coming into the real world, or having the user going into the virtual world, and so back and so forth, back and forth. And it's all very nice, but like we started to say in the beginning, the purpose was actually having the users interact with their environment around them and not having them interact in a very small area. So, and another thing actually mentioned was having the users move from one person into collaboration, having several users collaborating together, interacting together in the real world. So now actually I want to show you how we move from the small environment. What I've just showed you is actually interactions around the small environment into the big environment, to the entire room environment size. and how we move from one-person interaction to multi-user interaction. So the first demo I want to show you is actually what we call let's have it just a second. There we go. A collaborative farm. So it's actually based on the same farm story that you've seen so far. And this time we're going to use several users interacting together around this farm that you just seen. So you can see basically several users holding their tablets and the marker in the middle. And now we have the farm coming out, and each user can actually see the farm from his own point of view. So we have the same virtual object alive, so to say, in the real world, and each user can see him from his own different point of views. And in a moment, we're going to show how we can actually have the users interact with this farm in their own way, and we can see the users building their own world together. So in order to do that, we're going to have each user plant trees on the table around the farm. And each tree that one user plants, both of the users can actually see. So we have the users creating their own world together, planting trees. The next thing they're going to do is actually put sheep. So you can see how we have several sheep. You can see that trees appearing all around. This is the other person planting trees. And now you can see how one user puts sheep, and the other user can actually see these sheep where the first user has put them. So this is a nice example of collaboration. And another example would be, like I said, of course, Uncle Jeff is walking outside. You've already seen something similar, but they're both watching Uncle Jeff in the same area. And just a small sample for another interaction is how we can throw tomatoes at a table. So you can see how the first user is actually throwing tomatoes at a table. And the tomatoes are are being shot from the user, hitting the table and bouncing off the table. And both of the users can actually do that, can throw tomatoes. So of course you can take it to many different areas, to many different types and concepts. And this is actually a very nice example of how we do collaboration between two users. At this moment, I've been asked about this in the previous webinar, so I'm just mentioning that the collaboration itself between the two users is actually based on the network and the Wi-Fi. We have here another small example, I think, of object recognition. How we can put, for example, a real chest, and we can recognize that there is a real chest now on the table, and also a tractor. And now using the object recognition, we can actually put over the real chest, we can hide the real chest with a virtual chest, or put another virtual tractor above the real tractor. And like I said, you can take it to many different areas, to many different, you can do with it a lot of really cool stuff. So let's have a very, very quick answering some questions before we continue. All right. So I can see here partial questions. Get set tracking, but none of the examples. So we have here none of the examples deal with hands getting out of bounds issue, letting the user feedback from available tracking area. Well, that's correct. You haven't seen anything like that. We have something similar actually in the Unity toolkit, but basically having the user in order to tell the user that the hands are getting out of the bounds of the screen, or basically out of the camera's angles or point of views, what you're going to have to do is provide the user some sort of feedback. You're going to have to show him a sort of marker that indicates where he is on the screen, and if the marker is getting out of the screen, the user knows his hands are outside of the screen. We do something similar in the Unity toolkit. I'm going to hopefully get to it in time. We have RL asking regarding the face detection. Can your user detect custom gestures? For example, a blink of the eyes together with his mouth open, or is there a predefined set of gestures of the SDK detects? The same goes for 3D gestures. Can you detect gestures in 3D? For example, a fist coming from back to forth. So, all right, that's a pretty good question. Regarding the face, we currently do not offer, as far as I know, any gestures, as you call it. It's not really gestures, but any custom gestures detections, like a blink and so forth. You can detect expressions. So that's a smile, that is that is expression of surprise, but not necessarily a blink. What you can actually have is having, let's say, the location of the tip of the eye and the end of the eye. Then from that you can manually infer a blink, and then afterwards from that you can mix it up with data that comes from any other, let's say, SDK modules. Like if you want to also to understand as well whether the mouse is open or closed, so that's the same module. Like the face tracking, if you want to actually understand some more information about the depth of the hands, you can take that as well. Regarding the 3D depth gestures, so there are currently several gestures that are being provided. Some other gestures are going to have to be manually planned for the moment. There is a gesture authoring tool. I'm not 100% sure if it's provided already or not, but I think that the gesture authoring tool is not provided along with the SDK at the moment, but it is planned for the coming future. And the gesture authoring tool is supposed to provide you the ability to create your own gestures whatsoever. However, because you don't currently have it, that's at least what I'm assuming, so what you can do is, like I said, use the raw data in order to infer about what kind of other gesture you want to create. Like if you want to understand that there's a fist and the hand is moving back and forth, so what you're going to have to do is basically have the hand's location and track it and actually understand it's going back and forth, and also have the hand's openness and understand whether the hand is open or closed, and combine these two together. All right, so let's continue. So you've seen, like I said so far, multi-user interactions moving from small scale to large scale, and now I actually want to show you how we move from, let's say, table scale to a room scale. So in this demo, it's a bit complicated demo. I'm going to explain as we go. All right. So in this demo, we actually have, there we go. We have a multi-user interaction inside a room. You have 3 users flying a ship. Actually, the one user, that's me now, as you can see, I'm flying the ship with my hands, with my gestures, inside the room. And the other 2 users are holding tablets or compute devices, and they can see the ship flying inside the room. And both of them, like I said, seeing the same object flying in the room from their own point of views, and they can interact with it. So basically we have the ship coming into the room from the ceiling, from the clouds. The user don't really see ceiling, they see the clouds, and they both see the ship flying in the room. And the next thing that happens is actually the ship is being attacked, and we have all 3 users trying to defend the ship. So the pilot is trying to navigate the ship, running away. The ship is being attacked by dragons, and you can see the dragons flying around the ship. And the pilot tries to navigate the ship along as far as he can from the dragons, while the users are attacking the dragons, throwing fireballs. User interactions inside a big room. We're not constrained to the table anymore. We can move all around, and this is another actually a small concept demo. You can see how the birds are following the user. This is actually just to show how we understand the user's location in the room. So you can see how the user moves around and the birds are following. All right, we can stop right now. All right, so as you've seen so far, we have a lot of types of interactions. We moved from one user interaction to multi-user interaction, from small scale to large scale, and we move a lot from back and forth between the virtual world into real world. We try to combine all of these worlds together and actually remove the difference, actually blend them together, and we do that using the augmented reality, of course. All right, let's continue that. So we've seen the multi-user interaction, and now I want to talk to you a little bit about the challenges that comes along with augmented reality experiences. Along with all these new experiences, along with the camera and the SDK and the data it provides, we actually have a lot of challenges that comes along with them. For example, we have we're talking now this time about a lot of compute power that is required because we're handling a lot more data. This is three-dimensional data is a lot more than handling two-dimensional data, and therefore you have to have a more responsive device. You have to be very aware of your battery life. You have to have a robust platform. And this is basically what Intel is trying to do, to push forward the world of computers and into the next generation of computers. And in order to do that, and this comes straight along with all the new capabilities that if we want to have a natural interaction with a compute device, if we want to have a more natural, more intuitive interactions, we want the compute device to always listen, to always be aware of us. We have to have a better battery life and more responsiveness. And this is exactly what we're trying to do here. So the next area would be actually the Unity toolkit. And I'm not really sure how many of you guys are Unity developers. So maybe it would be a good idea to make a small poll just to understand how many of you are actually developing in Unity. Actually, there is a poll. I can see that not a lot of you. So I will actually, so I will give a brief intro just to give you the small concept of what you can do with the Unity toolkit, and then we'll continue. Now, just quick, see we have a couple of questions. So we have Ranjit asking, what's the difference between 2D and 3D face detection? So 2D face detection is actually legacy. There is no more 2D face detection. In the SDK in the 2014 SDK, you have a 3D face detection, which is a lot more robust. It can handle wider angles of the face. When you had a 2D face detection was based actually just on the RGB, just on the regular camera, and the 3D face detection is based on the depth camera as well, on the depth data. And so we can do a lot more robust detection and understanding, and it requires less compute power, of course. So this is basically the major difference. So I see here a small question about a lot of elements in the webinar from the last session. So for those of you who are asking about the last session, this is the same webinar actually as the last session.
Hey Zamir, it seems you have problem with sound. Okay, it's better.
I think I'm okay. All right. So for those of you who are not aware of what Unity is, well, Unity is a game development platform, and this is how it looks like. And it is very very successful lately. And what we actually did with the RealSense SDK is provide, along with the SDK, a plugin that connects to Unity and provides all these capabilities that you've seen so far. How it provides an easy integration of all these capabilities that you've seen so far into the Unity environment. So, like I said, the goal was actually making it easy to create RealSense content. We're talking about drag and drop capabilities. We want the users, instead of having the users actually diving into the RealSense SDK code and starting to open pipes and so forth, what we provide, and you will see that in a moment, is the drag and drop capabilities, minimal coding required. We stay aligned to the Unity interface, the one that Unity developers are already using as well. And we provide AR capabilities and many more. So let's have a look right now. So this is basically the Unity environment. What you can see here, for those of you who are less familiar with Unity, is this window right here is the game environment. The game is actually what the users that are playing the game can see. And above it we have the scene window. Here we can actually see the 3D world from all around. You can see here my camera, for example, the point, and I can actually move around and have a look at it from different angles. And the rest of these windows, I'm not going to get into technical details, but they basically contain all the objects in the game. So the first thing I want to show you is basically how we use the RealSense to create a very easy, very quick interaction. The first thing is once you import the Unity toolkit, what you will get is this folder here, RealSense Unity Toolkit folder. And this folder has a lot of interesting things, but the main thing would be the actions. So the actions is basically a bunch of scripts that provides you a drag and drop capabilities into the objects in the scene. Let's say, for example, you want to put there's an object tracking over your hand. So here, if you can see, you have a tracking action, and you can simply drag it into the object and have this object tracking your hand, and I will show that in a second. But it's really important for me to explain, for those of you who are not really familiar with Unity, that this is the way basically Unity works, is using scripts that you drag into a game objects. So let's have a quick look about how it works. Let's create, first of all, a cube. You can see the cube right here. I'm going to move it to the center screen, and maybe scale it a little bit so you can see it. There we go. Now, let's have some light in the scene so we can see it, and let's rotate the cube a little bit so we can see that it's a 3D cube. There we go. So far I haven't done anything special, nothing that has to do with the RealSense. Basically, we're talking about only Unity capabilities, and if I press play, I actually have just a cube sitting around the world. Nothing happens. So in order to add now RealSense capabilities, what I'm going to do is actually take a tracking action, for example, and throw it over the cube. So once I press on the cube, you can see here all the properties that this cube has. And we're going to ignore all the Unity properties and go straight into the tracking action. And what you can see here is actually how we have the tracking action that is being attached into the cube. So currently we're talking about hand tracking. And basically all I did was actually just drag and drop. And I can immediately press play. And I don't know if you can, well, let's also open the webcast so you can see me as well. There we go. So I'm guessing now you guys can see me. So basically what I can do now is basically just display my hand, and let's put a focus right here. And you can see how the cube immediately tracks my hand. I haven't done anything special, just throw the tracking cube. And we're talking about 3D tracking. We're talking about I can move back and forth in the world, and we're talking about orientation as well. You can see how the cube changes the orientation along with my hands. If I move my hands back and forth, if I move it to the right and to the left. And this was very simple. And now I can actually play, this tracking action comes along with a lot of features you can play with, a lot of, basically you can constraint, you can stop the tracking in a certain axis, or you can stop the rotation on a certain axis. You can invert it. You can define, actually there are a lot of features you can play with here along with. And very easily I can switch between hand tracking, for example, into face tracking, or into object tracking if I wanted to track over a certain object. Let's switch it to a face tracking, for example, and press play. And now you're going to see how the same cube is actually tracking my face right now. So let's have a look. There we go. So here we go. And you can see how when I move my face, the cube moves along with my face. I can go back and forth. And you can see the orientation as well. There we go. So I'm not, like I said, I don't want to go very technical with you guys. I just want to give you a small concept. What do we have? What does the Unity toolkit provide? So basically, what you can see here, like I said, is a bunch of scripts. For example, you have here like a tracking action, a translate action, which means you can actually hold your object, grab your hand and close it, and then move it from one place to another and release it, or do different gestures in order to play with it. You have a scale action, which means you can hold the object and scale it, or rotation action means you can rotate it from different angles. And a lot of actually cool stuff here. You have a hide action, which hides the action. You have several enable and disable behaviors, which allows you to do certain type of actions, which means that if this happens, so disable that behavior. Like if one thing happens, disable the tracking action, and then you don't have any more. The tracking stops or starts. So it's also important actually to say that all these features, all these capabilities that are provided along with the Unity Toolkit are open source. You have everything, all the code is open for you, and you can. It was built. The architecture that was planned was for you to have it very easily for you to be able. So you will be very. I'm sorry. So it will be very easy for you to change things and actually adapt them to what you guys need. So I'm going to show you a quick sample of what we did with the Unity Toolkit. Let's say the AR mirror is a good example in this case, because it provides a bunch of capabilities. So in this case, what we actually did is took a lot of objects and have them tracking over several elements. The first thing you can see is actually tracking over my face. You can see how I put tracking over my nose, my mouth. I use several landmarks, and you can see the tracking. If I put my hands as well, we took actually a bunch of objects and have them tracking over our hands. You can see the orientation, how we can move our hands and open and close them. This was done actually very quickly in a very simple way. I'm talking about about somewhere around an hour. Was just actually grabbing the scripts and throwing them over the objects, and then playing along with the parameters and having them having the right parameters that fit our needs. And of course, all the parameters and all the explanation about all these parameters is being are available freely on the documentation. So before I go through several demos, actually I'm not sure if I have time for it. So let's go over some questions and answers. And if we have time, I'm going to show you some demos of things we actually did in the Unity Toolkit itself. So we have Ranjit asking if he's saying, I do see the IR stream in camera viewer sample. Since IR is used for depth calculation, but is there any simple use case to use IR stream directly? Well, we haven't used the IR stream directly. No, I don't. So maybe you will find it suited for your needs, but as far as I'm aware of, there wasn't any usage that we have done with the IR stream directly. Arun is asking, how can we have a shadow of the hand movements on the screen while it is tracking the hand? For example, I have a virtual stick in a scene and I want to pick it up and throw it away. So basically, actually, we have that in a very good sample. So I will use this opportunity to show this demo that I want to show on anyways. Something we called actually real fishing. So what's actually nice to see in this demo is how we use the camera in a different way. This time, this camera is actually facing up, and you can see how when we move our hands above the camera, you can see the shadow of the hand. We can actually touch the screen. You can see the ripples in the water. And the point in this game is to provide the experience of going fishing. So you can see the shadow of the hand hovering above the water. And once the user goes closer, you can see the shadow goes closer. And it is pretty easy actually to do it. You can use either the point cloud, or you can use the hand tracking and imitate the shadow of the hand. But what you're gonna have to do, I'm not gonna go very technical again. So what you're gonna have to do is actually take the raw depth data that stands above the camera, and from it have a projection of it into 2D. Ashu is asking, can you please provide some guidance for app development in C#? So the SDK itself provides everything. All the SDK features are also available in C#. For those of you who are developing in C#, and you can actually see in the SDK folder where you have the binaries. I'm going to quickly show it right here. If you go to the SDK folder, you have right here the binaries. You can also have every binary that you have here, you have in C++ and in C#, and all of them are provided along with the actual code. So if you need samples, if you want to have a look about how something is being done, simply go into the SDK folder and have a look. And of course, everything is also available in the documentation itself. All right, next question. So we have Ariel asking, just a second, there we go. If we detect custom gestures coming from the raw data, how do we detect the user is making the same gesture? The user won't repeat the exact same gesture, but I assume similar set of X, Y, Z points. So again, this is a matter of how you understand things. In order to detect a certain gesture, what I would actually look for, let's say, for example, the one you were looking for previously was a fist being moved back and forth. So first of all, you have it in the Unity toolkit. You can see how this is being implemented over there. But the concept would be looking at the openness of the hand. You want to see that the hand is closed, and this doesn't really matter on which user is closing it and where is he closing it. But you want to see that the hand is closed, and then you want to see that it moves from the Z value of the hand changes into a certain amount. You don't want to make sure, you don't want to check whether it moves from point A to point B, but you want to look at the delta, the difference. You want to make sure that delta is bigger than a certain amount, and that it changes back and forth a couple of times, as many times as you want to check. All right. So let's see. I can see that. I feel it would be more productive to progress. YouTube will catch everything up to speed. Be my app, YouTube channel. All right. It doesn't. Where can I report the reliability problem with the 3D segmentation sample? It is a genuine problem, definitely not caused by the visual. So if you have any actual, and this is true for all of you guys, if you have any actual technical issues, so of course there's the technical channel. This is the right place to start reporting things and asking them. I would generally say it is either you're not using things correctly or there's an actual problem, of course. In the 3D segmentation issue, if it's a binary, there shouldn't be, this shouldn't happen. There should be actually an actual problem. All right. Do you need Unity Pro in order to use the Unity toolkit? Very good question. So basically, yes, you do need Unity Pro in order to use the Unity toolkit. Unity currently supports three third-party plugins only in the Pro version. However, there is, I've heard that there are ways around it. I'm not talking about illegal ways. I'm talking about, but basically, if you want, you can breeze through the internet and see if you can use the Unity free version some other way. At the moment, we don't really have any official agreement with Unity of having this embedded into Unity. So the answer would be yes. What is the presenter's email ID? Well, any other questions you have? Basically, I would suggest you guys not to go through me, but to go through Salim. So I'm sure he'll be able to answer all the technical issues. All right, so let's have a look about the last thing. Actually, see that I don't see any more questions at the moment. The last thing I actually want to show you is how we took the Unity samples and very easily created a nice interaction. We took a Unity game. This is a pre-built Unity game that's provided for free by Unity, and we connected to the camera the 3D, the face tracking. So you can see that when the user moves around his head, the camera tracks along with him. And so the user can actually take the player and hide behind a tree and then peek with his head, actually move his head to the right or to the left and peek around the tree and have the camera move around to the right and to the left. And this provides a lot more, a better experience of playing as well. Because when you move and you see the camera moving with you, even if it's a tiny movements, when these tiny movements move along, you feel like the user is actually looking through your eyes, and it provides a lot more immersive experience with the game. So this is something very nice, very easy to create, and just to give a small concept of the things you can do very quickly with the SDK and with Unity Toolkit. So another question we have here, how do you get the voice recognition to work correctly? The SDK says that the volume is too low. Well, again, a very technical question. I would recommend you using looking through the documentation. In general, there's a matter of which device you're listening to. So if the SDK is actually listening to another device, if you have several microphones, like a microphone in the camera, a microphone in the computer itself, and one of them is unmuted, so it might tell you that the volume is too low, although you put maximum volume. So this would be a good idea to have a look at that. Another question by Jerry. Can the RealSense SDK do basic image processing, filtering, and thresholding? All right. So we don't provide, along with the SDK, an actual image processing libraries. There are several things that are being provided. For example, there is a smoothing module that's provided along with the SDK. I think you can see it being used somewhere in the samples and definitely in the documentation. But in general, we don't provide the filtering and thresholding. We provide a higher level, which is the SDK itself, which provides you, of course, the hands tracking, and it gives you the direct location of the hand at every frame. And if you want to work even higher than that, then you can go straight into the things like the Unity Toolkit, which can actually give you tracking straight over the hand, for example. So this is that. Any other questions? I see we're almost out of time. All right. Seems like these are all. This is about it. So, everyone, thank you for your time.
Thank you very much, Nadav, for the presentation. Can you hear me?
Yes, yes.
Yeah. Okay. Perfect. Yeah. So yeah, thank you very much, for answering, all the questions. We are still, having, some other questions, popping up, but, I think we'll be replying by this, offline. We collect, all the questions and transcripting, sorry, the answer that Nadav provided, and we'll be sending you this by mail. For the videos, they will be available on the Bima app channel. They will be also included in the SumUp email. And just, one quick reminder. So as you can see it now on the screen, this is just one slide, to remind you for the $1,000 challenge, which is, for the early submission. So you can submit your apps before December 17th to be one of the 80% that will be selected by the jury. In fact, 80 is 50 for the pioneer track and 30 for the ambassador track. And this is completely something that you can make, with the also participation for the whole challenge. So you can submit one first demo for this early submission, and then you can for sure, continue working on it, and you can also finalize it. So before February 13th to be eligible for the final prize pool. The good thing with this is that we'll be having some big event, let's say, coming before the end of the big challenge. So if you are one of the luckiest 80 persons, you may be contacted by our marketing staff in order to showcase your app/project, I would say, at one of our big events, especially Mobile World Congress or IDF in Shenzhen. I don't know if there is any more question regarding the contest. Let me check. So yeah, I think that's it. I think it will be more easier for you guys now to follow already follow, say, the on YouTube. If you have any question, I already shared my email on the chat. So slim.soussi@intel.com. So don't hesitate to mail me. I will forward to the available technical expert because Nadav, thank you very much for your help here, but he's not really the person that will be always asking all the questions. And thank you, Alex, for organizing this meeting. Thank you, guys.
Thank you, everyone. Good luck.
Thank you. Cheers. Bye-bye.